Good morning. My name's Elaine Dorward-King, and I'm one of the WET Project board members, and I have the pleasure this morning of introducing our first speaker, Ricky Arnold, who is an astronaut, a mission specialist, and an educator astronaut. And as I got to know Ricky just a little bit and read his bio, I thought, what a fantastic background to be at this conference and to be on our board of directors. Ricky started out as an educator. He had got a bachelor's degree in his teacher certification in Maryland, went on to get a master's degree in marine biology and environmental science. He then worked globally around the world, in the Middle East, in Southeast Asia, and in Eastern Europe as a teacher. He then applied to NASA to be part of the astronaut program, was accepted, and completed his training in 2006. In addition to going into space, which he has done, he also has lived below the ocean in one of the world's only underwater laboratories, which is run by NOAA and the University of North Carolina. So he has a lot of interesting experiences to share with us, and a very different perspective, I think, on water education and the topics that we're going to talk about today. So it's my pleasure, Ricky, to turn it over to you.
Good morning. I have a couple of home movies I want to show you, and I also have a PowerPoint presentation, but it doesn't have any words printed on it other than the title. So if you're interested in seeing a few pictures from space and you can't see the screen, please feel free to move to a place where you can see. I'm sorry I upset the apple cart a little bit, but I won't bore you with the PowerPoint presentation, hopefully. I had the real honor to be selected as a representative of the teaching community when I was chosen to be an astronaut back in 2004. I was fortunate for a lot of reasons. Number one being that I was 40 years old and was able to pass the physical requirements to be selected. And I say that half jokingly, but to be honest, there were people far more qualified than I was to do this job who were deselected for reasons that, it's something that the NASA doctors were able to find, and this person would have lived to be 140 years old and never had any issue from this particular health issue. I think about 50% of the people end up not being selected because of the rigors of space travel and how difficult it can be on the human body. So without that, I just want to show you, I got the opportunity to fly on the Space Shuttle Discovery in 2004, and I have a few home movies I want to show you. I have some pictures I'd like to share with you, a few thoughts about our blue planet, and then I want to leave up some time for questions, because I know teachers and educators always have a lot of really good questions, and you'll think of things that you'd like to know about that I wouldn't have thought to share with you. So if we've got our technical difficulties solved, outstanding. I was chosen to be part of the team that delivered the last set of solar arrays to the International Space Station. And what that enabled us to do was to go to an international crew of 6 astronauts, and to carry out all the science in the European and Japanese lab and the American lab that we'd hoped to carry out when we got started. There was a crew of 7. I don't know if we had some volume here. If it's a... We were delivering a Japanese astronaut for a 4-month stay on the ISS and bringing home an American astronaut, Sandy, who'd already been up there for 4 years. This makes for a very exciting day. Someone was asking me the other day, what are you thinking here at this point? And
2, 1.
Really, at this point, you've surrendered to the madness. This is Sandy up on the ISS with the commander, Mike Spanky, and you can see Yuri up in the upper corner. And we went from standing still in Florida at sea level to traveling 17,000 miles an hour and being a little bit over 200 miles up in about 8.5 minutes, 200 miles up. And it is the best amusement park ride you could possibly imagine. These solid rocket motors fall off, and after about 2.5 minutes of flight, they actually end up landing off the coast of Jacksonville. So we've already traveled up to halfway the coast of Florida, and they are already kind of in visible space. Sandy had been waiting for us for a month, and until the main engine shut off, I don't think she really thought we were coming to get her. She was really ready to come home. This is the big orange tank that's built in New Orleans. That actually re-enters the Earth's atmosphere, and the remnants of it land in the Earth's ocean down near New Zealand. And 3 days later, we pull up to the ISS, which was built by 23 different countries around the world. If you take it and lay it out, it would cover a football field. The internal living volume is about the size of a 747, and it's the brightest object in the night sky apart from the moon. How many people have seen it flying over? Yeah, it's really easy to pick out. It's bright and it's fast. We dock to the ISS. You can get an idea of the altitude where we are just by looking at the Earth passing by in the background. This is sped up a little bit, so
Space Shuttle Discovery arriving.
and we pull in here after being crammed in this little tiny shuttle, and we're kind of like bull in a china closet once we get in this giant space station. Our primary objective was to deliver this big truss segment, which had the solar arrays. It was 34 feet long and weighed about 16 tons. So we were able to carry something about the size of a school bus up to orbit and use a robotic arm to install it. And this is me in the left hand. This is my hand out on a spacewalk, and we're basically guiding John, Koichi, and Sandy to drive the thing like backing a Winnebago into your garage. We then were able to deploy the solar arrays. We were just all sitting around the computer station watching this happen, but most of us were probably watching this beautiful image pass by underneath the arrays. We did 3 spacewalks, the big one getting the solar arrays installed. We had some stuff to deliver, and moving big heavy bags around on the ISS is a lot of fun. All the day-to-day stuff like exercise, trying to eat M&Ms, and then playing with water in an environment filled with expensive electronics. We also spent a lot of time, you can see the northern lights here, spent a lot of time just looking out the window whenever we had a chance.
Hello, Commander, can you hear us?
Welcome aboard the International Space Station. We hear you loud and clear, sir.
We got a surprise call from the White House. He had a group of about 45 middle school students who were there to ask questions, and I think the president and the senators there did all the talking, and the kids just got to listen. They were very excited to talk to us. We left our friend Koichi up on orbit for 6 months. He's actually going to go back and be commander of the International Space Station. And then we backed up in the shuttle and got to look at some of the work we did. You could actually see the arrays that we deployed, and we got to fly all the way around the ISS. This is obviously sped up. Our pilot would have liked to have flown this fast, but the guys down in Mission Control wouldn't have liked it. 13 days later, we are traveling around the world. We've got 16 sunrises and sunsets a day. We're going around the world about every 90 minutes. We turn the orbiter around and slow down only about 300 miles an hour. So we're going 17,000 miles an hour. We're only just a bare nudge over the coast of India. And 60 minutes later, we're landing in Florida as a glider. So our Air Force pilot, Lee Archambault, had one chance to get it right. This was his first time ever landing the space shuttle. He'd done a lot of practice before, and he did a great job. And those are kind of the quick highlights of the mission. If you saw anything there of interest, I'll be happy to answer questions when I get done. But I had a few other pictures that I've really never shown anyone before. In fact, I have to thank Dennis and the board and John for inviting me up here, because one of the real treats was I had to dig through 6,000 mission images, which you know how it is with family vacation pictures. You never really look at them all. And so I had the opportunity to dig through a lot of pictures and pull out a few that I thought were meaningful for this conference. And I also took a few pictures that were taken by colleagues of mine that I thought you'd be interested in. So, reflections on the blue planet. I think this image here is, and I'll share a little bit of history with you in a minute, is where this term came from. In fact, I looked it up on the internet, where the term blue planet, and Jim Lovell is credited with coming up with that name. He was the commander of Apollo 8 that took this picture. And when the guys came up around the moon, they were on a very technically challenging mission. I don't know if anyone knows the history, but the United States and Russia in 1968 and the Soviet Union were engaged in the Cold War. The space race was kind of a manifestation of that. We had, our intelligence agency had noticed the Russians putting a big, large rocket out to stack to launch. And it was probably their lunar rocket, and they ended up having trouble with it. And so our agency and our government decided we're not quite ready to go yet. We haven't done all the test flights we're supposed to do, but we have a rocket stacked. It doesn't have a lunar lander, but we could put 3 guys on it with no chance of landing on the moon and just shoot them to the moon, make them orbit a couple times, and then bring them back safely. The crew of Apollo 8 were given about a 50-50 chance of getting back alive. And so they were really obviously focused on the good 50% and trying to make the bad 50% happen. So I don't think any, and knowing some of these guys and how they think and work, they probably weren't thinking about this picture at all. They were probably coming around the moon, they were in orbit, they're probably pretty happy to be in orbit, and the thing that was probably on their mind was firing the engines that were going to take them out of lunar orbit to get them back home. And then all of a sudden, they come into the bright side of the moon and they see this beautiful planet coming up over the barren lunar surface, and they were scrambling to get pictures. And to this day, they don't agree on who actually took this picture, because they all want to take credit for it. But I think this is where the term blue planet came from. And, actually, I have control of this, don't I? I was giving John direction. I just wanted to share. Here's a kind of hard to see here in the bright room. This is actually Bozeman taken from space. And picking out cities is really hard during the day unless you have some sort of geographical marker as to where they are. But at night, you can really see the shapes of cities. We were coming across Canada, and I didn't know where we were. We were just looking out the window at night, and we were all supposed to be in bed. The commander comes. We were all sleeping on the space station. Okay, you guys are all lights out, aye, aye. And he goes to go to sleep, and of course we open up the windows and stay up for 4 or 5 hours. And we were coming down, and you could act like the coast of Chicago, silhouetted by the lakes. Tokyo, Japan, places you just pick out only by the light imprint that they make. You really would have difficulty finding during the day. Bozeman probably a difficult one to find during the day, but at night you can pick it out pretty easily. Again, here's this picture, Jim Lovell, Blue Planet, and here we are today. This is the ISS. When we went to the moon, it was a 4-day trip, 400,000 kilometers away. Right now we're orbiting about 350, 400 kilometers above the Earth. So our vision of the planet is a lot different than the guys who went to the moon. However, it is a stunning image when you get a chance to look down. And this is the International Space Station at completion just about, in orbit, going around 16 sunrises and 16 sunsets a day, going around every 90 minutes around the Earth with a crew of 6 currently. Actually, there's a guy landing tonight. Here was Tony and I getting ready to strap into Discovery. You can see Discovery right behind his hand. That's actually the hatch. On that hatch is a little tiny window that for some reason the engineers hate windows. Anyway, there's no reason you have to look outside, but they have this little tiny window. Windows are challenging because they break. So engineers don't like them. So we have this little tiny window which didn't have a UV filter on it, and built into the glass, and so if you happen to stand by that window, you could get a wicked sunburn. So one of my first jobs on getting to orbit was to install a little UV filter. It's a really trivial kind of job, but you open up this little window, put the UV filter on, and we had actually launched into nighttime, and so when you get out to orbit, you don't really see anything. You could have been in a simulator back in Houston, for all I knew. However, when I went to remove and install the UV filter, Earth had passed into daylight. And so I opened the window, put the filter on, and all of a sudden I have this face full of this planet spinning by us at just an amazing rate of speed, and it was just a breathtaking view. So we're here, we're all smiles, getting ready to go. I was noticing here, I don't know what's in this cooler, but we never found any beer on the shuttle with us, so I was thinking that was for the guys there. And here we are taking off, and I already talked a little bit about liftoff. Here's a picture taken from the beach down at Canaveral Air Station. And I've been at NASA 7 years, and every day on the website they have a NASA picture of the day. Does anyone subscribe to that? I see a couple people nod. And I think I've been a photo of the day twice, which is pretty impressive given my face for radio. But this was the first one, taken on our first spacewalk, and I'm out at the very end of the truss. We are about halfway through the job. We happen to have a camera there. Steve Swanson, I was with, hey, go ahead and let me get a picture of you sitting here hanging on. And this picture became a picture of the day, and I kind of like it because it was my first time out in space, and I was out there with a good friend of mine. But the other thing I kind of find really fascinating, and it's really hard to see, but you can really pick out the Earth's atmosphere and just what a thin, unimpressive ribbon it is. That is one of the most profound memories I have from being in orbit, is when you look at the atmosphere and how insignificant and inconsequential it is. There's absolutely no way that you can pump all the stuff we're pumping into it and have no impact. There's just no way. And the other picture of the day was better for a whole host of reasons. Number one is my visor was down. But this was taken on our second spacewalk, and Joe Akaba actually took it. You can actually see him in the reflection from the gold foil on the visor right here. But if you magnify this picture on the helmet, it just has an amazing view. So it really gives you a sense for what your visor is full of the whole time you're working when you get a chance to look down. Here's Joe. You can actually see him with the camera in his hand. Here's the tail of the orbiter. So here's Discovery right here. You can see my hand, my other hand hanging on for dear life, and then just an amazing planet beneath you. This is actually me working on the Canadian Robotic Arm. I'm actually, and this is one of the challenges with spacewalk, you don't really get to spend a lot of time looking at, you know, the guy's taking this picture, like, oh wow, what a great picture. I'm hanging upside down with my back pointed to the earth, looking up into space, trying to do some dental work on the Canadian Robotic Arm right here. So a good chunk of your time, you don't have a lot of opportunity to sit and really enjoy what you're looking at. And then, so this was one of our primary tasks on our third spacewalk. And during a spacewalk, you are in a kind of a hard shell suit. It's the world's smallest spacecraft. It has its own environmental life support system. It has its own communication system, own heating and cooling system. And it is in no way attached in an umbilical to the ISS. It's all ISS, you're all self-contained. And you're in the suit for about 10 hours. It's kind of a hard tortoise shell. You got to squeeze yourself up in, put the helmet on, you put the rest of the outfit on. It takes about 4 hours to get ready to go outside, and then you're outside for about 6.5, maybe 7 hours. It's an amazing, amazing machine. And this is another picture I wanted to share with you that I had never known it was taken until I was going through some slides last week. Tony caught me not working. So Joe was up here somewhere doing something on the robotic arm, and I distinctly remember this moment. This is one of the few moments I was able to grab for myself. He was busy doing something, so they were talking to him, and I just kind of tuned him out. And you can see I'm hanging on here, obviously not working, and my face is pointed down to the earth. And these few moments that you're able to steal are just indescribable. You can see these monstrous thunderstorms below. We're probably somewhere in the equatorial zone. These clouds are probably 40,000, 50,000 feet high. You can see lightning from them, and at night it'll actually light up the cabin of the shuttle that much higher above the thunderstorms. When you really get a chance, there's no one talking. Sometimes you have lapses in calm with Houston, and you can sit there and just very gently let go of the space station. You're tethered to it with a little cable and hook, and float alongside, in your own little spaceship, and just kind of watch this planet pass by underneath. It's absolutely breathtaking. And one of the people say, well, what are you thinking then? You're thinking, I wish I could bring all my friends and family up here and do this with me. We would take a lot better care of our planet if everyone had the opportunity to see how really precious it was. This is really the only time I wasn't working. The other time I was doing really good work with your tax dollars. Here's kind of some of the images you get to see looking out. I remember during one pass coming up the East Coast right before there was a couple of opportunities. This is probably in the South Pacific somewhere. You can see a coral atoll. Right here, there's two of them. They're very distinct, stand out, look incredibly fragile from space. Very beautiful colors from the water. You can't really capture the color of the Earth here. It's a color that I've never seen anywhere in nature other than from orbit, and it's kind of a color that's forever burned in my head. If that's one thing I'll remember, it's just this brilliant, brilliant blue color. Yeah, very flattering photograph. I'm trying to figure out, obviously, how to work a camera. And this is actually taken in the cockpit of the shuttle, so you can see stuff Velcroed everywhere. There's a camera, I think there's a video camera up here. There's some cue cards that I made up for all the pictures I wanted to get. I was in charge of all of our photography, and I distinctly remember during our training saying to the photo trainers about, hey, what about taking pictures of Earth? I said, we're not going to have time for that. We got guys on the ISS who are up there for 6 months. They're up there on weekends and holidays. They're up there at night. They have time off. They take amazing pictures. They get really, really good at photography. If I want any picture of Earth, I'll just go and get one of theirs. And that held true for the first 11 days of the mission. But when we undocked from the ISS and I actually had a little bit of time to start looking out the window, I started trying to figure out how to use a camera and take pictures of the Earth really quickly. And this is some of the reason why. When you just get a chance, you just want to bring home a few memories to share with people. And I really got started, the guy right here, John Phillips, is one of the guys who spent 6 months on orbit, and he had taken some amazing pictures. And so one day he comes running up and says, well, floating up and says, hey, we're going to pass over Mecca, Medina, and Jeddah. And they're really cool cities to see from space. So I said, all right, you got me up in the, and he knew I'd lived in Riyadh for a number of years. And so we got up and started looking for it. And we actually started getting in position as we were coming across the Atlantic Ocean and going to pass over North Africa before heading over to Riyadh and then up through Central Asia. And I had a few shots that I took while we were doing this. Coming across Africa, you are just impressed by just how much desert there is there. And two images. One, I talked to you about the blue of the planet from the color of the Earth and the atmosphere. But when you're looking at land, the land that you see, how uninhabitable it looks. Most of it is desert. You see very little lush green vegetation. You see a little bit. We saw a little in New Zealand. You don't really see the rainforest all that clearly because it's usually obscured in clouds. So the land that you mostly see is land that just doesn't look fit to live, although civilization has made a run at it for thousands of years. So anyone recognize this body of water? So this is Lake Nasser in Egypt. And and if it was a little bit darker in here, you can actually see some of the very small circular imprints of where people are trying to farm with irrigation. The really only kind of hint you see of anything remotely water-like coming over all of North Africa. And then you head on up. And right here, this is the Jordan, Israel, the Sinai Peninsula. And then you see this amazing ribbon of green, which the green doesn't really stand out too well here, which is the Nile Valley. And then as we head on up, you're going to obviously pass through the Fertile Crescent, the Tigris and Euphrates rivers. And it's very eye-opening that this is the cradle of civilization. And what a harsh environment it appears to be from space because of the lack of access to water. And when you do have water, it's very vibrant and lush. And this is the Dead Sea. Yeah, pick that a little bit better. Okay, no, that's good, thanks. So Dead Sea and the coast of the Mediterranean. King's Highway runs up along here. And this is all of Jordan. You can see some signs of habitation, but mostly it looks pretty stark. This is not a picture that I took. This is a picture that Leroy Chow actually sent me from the International Space Station. That's one really nice thing about having a buddy or a friend who's working on orbit. Every now and then you get weird phone calls, and because they have an IP phone up there, or you get someone sending you a picture that they think you might like. And I had just started to work there, and Leroy said, hey, didn't you live in Morocco, or didn't you live in Algeria? And I had to write him back, and he sent this picture to me of the dunes in the Sahara in Algeria. And I wrote back and said, no, actually I lived in Morocco. So 2 days later, when they passed over Morocco, I got another couple sets of pictures. And compare that to, this is the surface of Mars. And you can actually see traces where water flowed. And we don't know why water doesn't flow there anymore. But we think if water was flowing there, that's a place where we would have found life. That's why geologists are really keen to send people there. This is you're catching, I think these are called noctilucent clouds, very, very high altitude clouds that you can only see in the very top of the atmosphere, just past orbital sunset. And you can get a fair view of what the atmosphere looks like. Some of the other water that you actually see, apart from what's in the ocean, is mostly cloud. This is actually the interaction of ice and clouds, because we were flying in March. A lot of water caught up in storms. This was a huge low pressure system that was down in the Southern Ocean visible for a couple days, and we took a couple pictures of it, but it was really impressive flying over. It was a massive storm. It must have covered, you know, it would have covered a good chunk of a continent. Just huge. And every now and then you see some lakes. I talked about the Great Lakes. They're fairly visible from space. Anyone recognize this lake? Yeah, it's Crater Lake. Yeah, it was an easy one to pick out. This was actually with an 800mm lens. I took this. We flew over Crater Lake and flew right over Glacier National Park, which I do have some pictures of that, but mountains don't really show very well looking straight down. You kind of get an edge-on view, and we didn't really have a good window to get an edge-on view. But this is the old Caldera Crater Lake, and you can see the little kind of island that you see. I think there's a tourist rest stop right here where you pull over and have a look.
Wizard Island, isn't it?
Yeah, I can't remember. Yeah, that sounds familiar. Other bodies of fresh water that you can see you can see the signs of evaporation as the salt deposits build up along the bank, right down here as well. We've actually photo documented pretty much the disappearance of Lake Chad from space, and astronauts have seen that happening as we've been flying in space for the last 50 years. Great view of the atmosphere as well. Anyone recognize this island? It's a Sable Island. Yeah, yeah, exactly. Very good, very good. This was a nice pass we had up the Atlantic coast. You can also capture the interplay between the ocean and the land. You can see sea breeze clouds forming as the warm, moist air rolls in and forms rows. Typically happens in Florida a lot during the summertime. I don't remember where this picture was taken. And man's folly in the desert. Signs of irrigation, a little bit in the way of reservoirs. And this almost looks like some of the stuff that you see, the carvings in, is it in Peru? Mm-hmm. In places where, this was actually a place where you could actually see a lot of forestation, and then obviously a lot of habitation around this great harbor here. And I think this was in Italy, but I can't remember for sure, and I'd have to go back and kind of align these up with Google Earth, because we don't have a geotag, unfortunately, like you would on an iPhone. So you got to kind of go back and try to remember where they were. And yeah, sunset from space is pretty magnificent. See the planets right here and just the thin layer of atmosphere. So we have this orbital platform up there where folks have been observing a lot of things for the past 10 years. You count the Mir Space Station, Skylab, we've had folks in orbit for a really long time looking at some of the changes on Earth. We've seen the desertification of large swaths of land, just turning what was once arable land into desert. This is Madagascar. This was taken by John Phillips when he was on Expedition 11. He described the country as bleeding into the ocean. And you can just see, this is all true color, just the soil runoff into the ocean. And I don't know if it's an apocryphal story or not, but there was an astronaut who met the president of Madagascar and actually said, "Oh yeah, you're the guy whose country is washing out to sea." We have seen the retreat of glaciers. You can see this image here, the breakup. Anyone recognize this island? It's close. This is Bermuda. Bermuda was is because it has a lot of fresh water on it. There's actually a place I know near, I did a month of work there in graduate school, and there's a place called Seven Wells, which has some fresh water, which was, mariners used to stop there all the time to reload fresh water. But you can also document and see the challenges from sea level rise. Places like this, the Maldives, and all those coral atolls that we showed pictures of earlier, and the risk they face as the sea level continues to rise. The dramatic La Nina and El Nino cycles that have amplified over the past 20 to 30 years. This is actually taken by Mike Fossum just 2 weeks ago. He's a Texan, and from Texas. There's all of us are Texans now because most of the astronauts live down there because we train in Houston. But he's actually a real guy, wears cowboy boots and looks like a Texan and talks like a Texan. He just sent this picture down. These are some of the fires in Texas. As you know, or maybe you don't know, we're under the worst drought in recorded history. And because they've amplified La Nina, they believe that this drought will carry on at least until another year. And you can actually see the plumes from the smoke from the fires. We had huge stands of loblolly pine, which have been there for forever. And they had basically just turned to brown and are now ablaze. So this is actually Houston down here. This is Galveston Bay, and NASA is located. We all live and work right about here. And everyone maybe or maybe not is familiar with Galveston and Hurricane Ike. The reason Ike came through and basically just washed over both islands. The greatest natural history actually in the United States occurred on Galveston. We had 10 to 15,000 people die in 1900 when a massive hurricane came through. And Ike came through and almost followed a very similar path with a lot of damage. And while we're in the Gulf of Mexico, this was taken by Doug Wheelock. You can see the outlines of the oil slick from the massive oil spill from BP last year. This is the Mississippi River and the delta of the Mississippi. This whole area is just sinking into the Gulf due to irrigation and subsidence, and probably also has to do with the extraction industry. There's a whole lot of subsidence going on in the Gulf of Mexico. Galveston is sinking. Most of Louisiana is sinking. But you don't hear a lot of talk about the fact that when you're pulling stuff out of the substrate, there's going to be an impact to it. And I was talking about hurricanes later. We've been able to document the strengthening and frequency of Atlantic and Pacific storms. Anyone recognize this city? The big bend in the river should be a hint. This is the Mississippi. This is New Orleans. Yeah, this is I-10 going across Lake Pontchartrain. And up in the upper right-hand corner, this is the NASA facility where they build the external tanks. And you can see in this picture, this is after Hurricane Katrina. This is actually the only place that's green. And we had a few heroic guys who rode out the storm. Most of them lost their houses and kept the pumps running at night. And this was where almost all the federal response to Hurricane Katrina was launched from, because these guys stayed and kept things, and actually probably saved the space shuttle program while they were at it. I think there were 30 of them, and they got NASA Medal of Valors, which have only been given to a handful of people. And they got 30 of them for these guys who rode out the storm. And there's a little bit close-up image here. You can see the NASA facility here. We use it to build the tanks, and we put them on barges and send them around to Kennedy Space Center. And if you look closely, there's green, and the rest of this is all water sitting in neighborhoods. You can see water coming over the roads, over the bridges. And two final thoughts, because I do want to give you a chance to ask a few questions. I talked about Mars earlier. We're really fired up about Mars because we think water used to be there. And if there was water there, there was probably life there. Might not be life there now, but why was there water on Mars at one point, and what was the climatic trigger that made it become uninhabitable for whatever might have been there? Where did the water go and why? It's an important question. And it's a great model for what might be happening. Who knows what's going to happen here? Hopefully it won't be that dramatic. But we're excited about that because we think life might have been there. We're also excited about this place. This is one of the moons of Jupiter. And these are actually fissures and crevices in ice. And we believe that due to the huge gravitational pull of Jupiter, it basically keeps this moon's insides all twisted up from gravity, which generates heat. And so you have this layer of ice way out, way past the sun, where there shouldn't even be any ice there. And underneath, we think there's probably liquid water that will actually bubble up intermittently through these cracks in ice. So we would really like to get a probe there and see what's going on. Again, because there's water there. So we have this orbital platform. We're able to observe all these things. We're dealing with similar challenges. We make our own water up there because that's the precious resource. We actually recycle urine and provides drinking water and all the water we need to sustain life on the International Space Station. We have to recycle our atmosphere. And we have to be able to generate electricity and provide power. And we have to do it in a really harsh and unforgiving environment. But we have an international group of people working together to solve these set challenges and solving, I think, some of the challenges we face here on Earth. So it's a real pleasure for me to be here, which I consider a very similar group of kind of people. I think we share a kind of a similar interest and a similar mission. You guys are here, you're working without boundaries. You're solving global problems by taking action locally. And for that, it's a real honor for me to be here, and I really applaud all your efforts. And the key is education. And so with that, I'm done with my pictures. If any of you guys have any questions, I'd be happy to spend some time answering them if I have a few minutes. Did I talk too long?
No, you haven't.
Okay.
Do you see any thinning in the already thin atmosphere?
No, well, no. Most of our stuff, a lot of the pictures we're taking and the images we're capturing are, it's not empirically derived data. So when we're up there, we're basically observing long-term trends. Folks like Goddard Space Flight Center would be ones with the satellites keeping track of what's going on with the atmosphere. And we're having real challenges with funding. Everyone's really happy in the United States right now, and actually around the world, with the job that the National Hurricane Center does, getting people out of the way of these massive storms. Well, the satellites that are keeping track of that and able to provide the data are old and failing, and the replacements aren't getting funded to the level that they need to be. So I think we're in a little bit better funding situation now for observing Earth's atmosphere and the Earth, but it's still a big challenge for us. This is a really good question. Yes, sir.
The thought that the water on our planet came here off of meteorites. Anything about this?
I've heard, not only water, but some of maybe the building blocks of life or primitive life forms have been sent here by, by an impact. They were carried on a meteorite or some sort of impact, or maybe a comet. Yeah, I've heard that, but I don't know if that. I think what we're going to find, this is just my own perception, is that water is going to be a little bit more abundant than we thought it was in the solar system and out in the universe. When I was in school, the only planet, this was the water planet. Well, oh wait a second, Mars has water, and now we think maybe Europa has water. And where you have water, we hope that you can find indications of life.
It could be truly universal.
It could be.
And that's an exciting thought.
Absolutely. And the contrast to that is that this could be a really unique place. And I tend to think more like you do, but the contrast is this could be a really unique place, which makes the responsibility for preserving it self-preservation. But if this is all we got, we should be taking better care of it. Other questions? Yes, ma'am.
What would be your recommendation? Saying that I can see in your background that you are providing education as well. What would be one of the main recommendations that you would include in a curricula of education and promotion and preservation of the environment?
Stop.
Would you repeat the question for her?
Yeah, absolutely. She was asking my recommendation for curriculum for instruction of science. Did I paraphrase that correctly?
Yes, preservation and to improve the education.
Improve the education for environmental science?
Exactly.
Okay. I think number one, it's just my opinion, and this stop teaching kids how to fill in bubbles on exams. Start teaching them how to get their hands dirty and solving problems. And that's one of the reasons I'm really excited about what you guys do. It's because kids get their hands dirty and they're scientists. They learn that science is a process. It's a vibrant, challenging, exciting career. And it's really important that your citizenship, that your citizens have the ability to make informed science decisions. And the more we teach folks that science is just a collection of facts that you memorize, the fewer scientists we have, and the policy decisions, there's implications. I'm not sure if I answered your question, but I think that applies to science completely. And environmental science is a great science to get your hands dirty. Yes, ma'am.
I have a question about, you're showing the atmosphere, and we've heard that there's coal in the ozone layer and that kind of thing.
Right. No, that's not visible with the naked eye, but it's there. And that's actually basically kept track using satellites. Yes, sir. You have your hand up.
How do you respond to scientists and politicians, a limited group of scientists, on the climate change debate as to it being a theory rather than a reality?
That's part of the problem is with not having an informed citizenry. To be honest, the data's there. The science community is not in disagreement. The problem is that scientists are busy with their heads down doing science, and sometimes people end up listening to the loudest noise rather than the most rational noise.
Well, that's why education, I think, is indeed the key, because
absolutely.
One child influences 3 who influence 10, and eventually you have informed citizenry.
Absolutely.
In terms of the science, I think.
Absolutely. Policy decisions come from, they come from a lack of informed citizenry, or a really informed citizenry. And we're living in a democracy. If you have a substantial majority of the people who understand the process of science and are able to, look at data objectively and come to rational conclusions and understand, what a theory is versus what a hypothesis is, then it makes life a lot more easy to make good decisions. You made a great point. Yes, sir.
Actually, to follow up on that, there is tonight at 7 o'clock. It's called 24 Hours of Reality. It's Climate Project.
Right.
And they're actually showing, it's in 7 o'clock in each time zone online. It's showing some of the impacts of climate and what the scientists are saying about it. And it's going around the world at 7 o'clock on each time zone.
Oh, nice.
And actually, the one that's being broadcast in our time zone is one of our Project Wet facilitators from California is leading that discussion.
Very good.
So he's broadcasting out of Denver.
Very good. Yes, ma'am.
Yeah, kind of a corollary to 2 other questions that were asked. And when you spoke, it sounded like when you first looked back at Earth, that you really got across that you were humbled by that. And so, how could we best get across that fragility of the planet as educators when we start everything wrong?
Wow. Unfortunately, it's going to be a while before we can take everyone up and give them that view. However, I think in everyone's backyard, there are places you can go and look and see how fragile things can be. I know growing up in certain areas, I grew up in Chesapeake Bay. And I remember going and catching all the rockfish you could catch. And then I remember years and years and years where there were no rockfish. And I think everyone has a local story like that that they can tell that makes sense to the person that's hearing the story. And then if you, the trick is to, hey, these problems are occurring everywhere. We then got a really fragile biosphere. Yes, sir.
My question is there a way to get this picture downloaded somewhere?
Which, oh yeah, they're NASA. These are all, they're all out there. NASA, go to the NASA website and go to NASA Images, and actually using Google is pretty easy too, and they will take you to, you can get high resolution photographs and print them out, and they're beautiful pictures.
Because I don't see a code length on this.
There's a code down in the lower.
No, on the station.
Sorry?
Because you do everything with solar. And it's reliable, right?
Oh yeah, yeah, all clean energy.
Here in the United States, solar is not reliable. We should go back to what status code. So I'm trying just to show this picture. There's no code.
Yeah.
No extension for it.
Yeah, and this solar technology, you know, it took a long time to build these. These panels are probably very inefficient because they were engineered 25 years ago, probably built 15 years ago or 20 years ago, and then launched. The last set went up in 2009. So if we were able to actually put new stuff on there, I mean, these are probably really old solar cells that probably aren't nearly as efficient at generating power.
And how something like the Teflon came from space, for example, or maybe other things. How can we get this stuff to us to use it?
You raised a very good question. I see John's starting to look at his watch. You getting close? 5 minutes? Okay, good. My own view, when people ask me about, and I'm going to take a step back and answer a question that you're not really asking, if that's okay. And then maybe within that answer, I will answer your question. But my own view is, much like the space station, we often get asked, hey, why are we spending money doing this kind of stuff? And number one, here's my number one opinion, is really, it was not a significant investment given it was 23 countries. But it's 23 countries that last century were involved in world wars and Cold Wars. And so what we have done is we've taken put a stake out in the future and said, hey, we're going to build an international space station. We're going to use all these different countries to come together. We're going to assemble these parts. We're going to have to develop hardware that we don't even, and materials that don't even exist yet to make it happen. And then when we get all that together, we're going to cooperate and build this lab where we have to learn to work and play together nicely. So, and in the process, when you make those kind of bold leaps, which humans have done ever since humans have first, started hanging around in cities together and started off exploring, going over the mountain to look and see what is there, we've learned stuff. And we learn stuff you don't expect to learn. So that's why I'm very passionate about it. Yeah, we need to go back to the moon, perhaps, or on to Mars. And yeah, right now with the technology we have, it's really difficult, it's really challenging, it's going to cost some money. We can't say beforehand what we're going to learn. That's how science works, right? That's how engineering works. But if we're working together to solve these complex problems, there are all kinds of trickle-down benefits to society. Some that you can't quantify, like international cooperation, the benefits to science and our understanding, but some that you can quantify, the new materials that are manufactured, the new manufacturing processes, the way you engineer and design things to put them together, the different kinds of devices. We have this urine recycling facility on the space station. And Koichi, who we took up, was one of the first guys to drink processed water. We always joke that we participated in the experiment, but we weren't test subjects. So, I mean, did I kind of answer your question there?
We need more education.
More education, and you can't always know what you're going to learn when you set off on a voyage. Are we good? Well, folks, John's giving me the hook here, but I am around, and I'm happy to sit and visit with you. My name's Ricky. Just come up and say hi. If you got any questions, I'll try to answer them, and I promise I won't break out another PowerPoint presentation for you. I don't know if anyone else can make that promise today. John, can you make that promise? Okay, all right. So thank you very much for your time.